Okay, dear students, so let us move to the next type, and this type is very different and quite confusing. So that is why this is very important video. Please do watch this video completely. Okay, so this is another type of questions that we have. Like you need to prove the proposal with the help of principle of mathematical induction. When u1 is given as 2, and then see there is a sequence that is given here. So what is the method of giving a sequence? They give you a couple of terms like 2, 3, 4, and then they give you the nth term. That is how we generally have the sequences. But in this particular case, it is not the case. You see, we have the first term and we have the formulation for the nth term also. But we do have some another thing. Now, what is this thing? Now, this is another formula for the next term. So this is, you can call it next term. This is nth term. This is nth term, but this is the next term. Why I'm calling it next term? Because if you know what is u1, only then you would be able to find u2. Because un plus 1 is given in the terms of un. So until unless you don't know the previous term, this formula cannot be used to generate the sequence. So for that case, you have to use this formula, that is un. But we are not using un here now. So how to prove this kind of question with mathematical induction? So first of all, we are going to have our step number one. So that's very easy. U1 is given as 2, and we are now going to prove it that if n is equal to 1 by this formulation, un is coming out to be equal to 2 indeed. Let us see. So not un. So u1 is 2 raised to power 2 minus 1 divided by 1 factorial. So 2 raised to power 1 divided by 1 factorial comes out to be equal to 2. So indeed, our proposition is correct for n is equal to 1. So now we are moving to step number 2, and we make an assumption here. Now what is that assumption? We make assumption for uk, that in this formulation we put n is equal to k. So we create one particular term which was earlier not created. So 2 raised to power 2 minus k divided by k factorial. And we make this assumption that this is true. This is our assumption. So step number 3 is that we now find the another term, that is uk plus 1. Now this is what we want to find. So we have taken this uk term, we have taken. So from this formulation, we are now going to find the next term. So the next term is uk plus 1. So according to this formula, it will be coming out to be uk divided by twice of k plus 1. Now we have to see whether this thing comes into agreement with this thing. Okay, I will show you how. So first of all, we are going to substitute this value here in uk. 2 raised to power 2 minus k divided by k factorial. 2 is already present in the denominator, k plus 1 is also present. So these two can be taken into the exponent as minus 1, and in the denominator we can write it as k plus 1 factorial. So we have found k plus 1. So in another manner, we can write that uk plus 1 is equal to 2 raised to power 2 minus k plus 1. You see, we could have subtracted 1 out of 2, and I can write it as 1 minus k, but that will not serve my purpose. That will become another lock for me, and I will be failed in this question. I will not be able to prove things. So I have this hint that if this is n, so I have to get n here. So this is k plus 1, so I have to get k plus 1 in the numerator. And there we are. So it becomes k plus 1 factorial. So definitely, if I say that n is equal to k plus 1, here I am getting this same particular thing. You see, k plus 1, n is k plus 1, so 2 raised to power 2 minus k plus 1 divided by n factorial means divided by k plus 1 factorial. Yes, this is proved now, but only on one premise, that uk is equal to this is true. So under this assumption, my step number 3, that is uk plus 1, is absolutely true. Okay, so this is how we do these kind of questions. All the best.